Plusmoro DSTN is programmed on.
Dar es Salaam, Tanzania. That is Tanzania. And environmental engineering.
His Excellency Mr. Farooq Amir, the Ambassador of Pakistan, His Excellency Mr. Ramadan Kumar Latrai, the Ambassador of Nepal, and Dr. Douglas Clark, GEOSS Secretariat, Dr. K.S.K. Shirai, the Deputy Director General of the Ministry of Education, Culture, Sports and Technology, Mr. Shizuo Yamamoto, the Executive, Dr. Akio Takemoto, the Director of the Asian Pacific Network for Global Change Research, Secretary. Distinguished guests, ladies and gentlemen, it is my great honor to host this development symposium. The Global Earth Observation System, GEOSS, Joint Asia Africa Water Cycle Symposium, here at the main campus of the University of Tokyo.
我が国は地球環境問題の解決につきましては、関心を共有する諸外国との連携による観測及び研究等の実施を通じて行うことを基本方針というふうにしております。地球環境問題解決における基本方針と一致するものでございます。このような AWCI および ASWCCI のアプローチは地球環境問題、地球環境課題の解決のための、科学技術の応用の実践として先駆的なものであると考えております。
In January this year, the Japanese government established the basic plan on space policy. This plan emphasized the importance of expanding the utilization of space. The basic plan also says that an important purpose of space utilization is to create new services and products for the improvement in quality of the people's lives.
We are funding the agency to support global change research activities funded by Japan, USA, Republic of Korea, and New Zealand governments. Various kinds of projects since the launch of our organization, such as the water issues related to climate change and ecosystems and land use. Most of those are cross-cutting research topics.
JAXA's Advanced Space Application for Environment SAFE project in Pakistan, monitoring water cycle variations and assessing the climate change impact on them in Pakistan, was an excellent effort to promote space applications in the environmental.
I am privileged to attend the GEOSS Joint Asia-Africa Water Cycle Symposium being held at the Ito Interim Research Center of the University of Tokyo, and thank the organizers for kindly inviting me to be with such a galaxy of intellectuals, academics, planners and decision makers. Asia is considered to be a continent of activities, with some countries making rapid socio-economic progress, while it also has the largest concentration of poverty in the world.
It's impossible to give a detailed explication of every single requirement for the water sector. We have a document that's under production now within GEO. Many of you here have contributed to it. It's the GEOSS Water Strategy Report, and that would be a good reference point to go to for details. But I would like to sketch for you just kind of the situation in terms of water, and then what kinds of capabilities GEOSS is providing to hopefully respond to the needs in those sectors. There is the WMO, there is the European Environment Agency, who are members, participating organizations within GEO, and so we're working with them to get at the issue of coordination and support for in situ measuring systems.
The water cycle is one of the key components of the current system. How to address these issues? We can develop a hydrological model which can simulate the parameter which is not directly observed by the satellite. Also, we can assess the climate change impact on the water resources and then develop the adaptation capacity. We can assess the water resources, climate change impact on the water resources in each country.
地球観測データを活用しまして、長期のプレーンというものをしています。一番左にレインフォール、次に蒸発、エバポレーション、そこからレインフォールマイナスエバポレーションということで、全体。
Basically, we believe in this kind of multi-step strategy for improving the adaptive capacity, but particularly at the sector level. And this step starts from awareness raising, that is building the scientific understanding and the capacity at the local level. We believe that is these knowledge gaps, particularly the uncertainties in the climate science and the limited public awareness, can be rectified by the knowledge institutes and the knowledge networks like GEOSS.
アフリカの持続的な成長には総合的な水資源管理に基づいた水インフラの整備は欠かせません。特に貯水インフラの整備なども重要であります。また気候変動の影響によって渇水、茶どこの例があるように湖の縮小や洪水などの増加が懸念されておりまして、防災対策も含めましてこれらに対する対応が重要になってきております。またアフリカには80とも言われる国境河川がありまして、その流域マスタープランの整備など流域国家の協力に基づいた開発が不可欠でございます。そして特に衛星を使った観測システムはアフリカの陸地圏が徹底的に重要な分野でございまして、そのシステムが
1999年、あとに天気情報、そういったものを衛星情報、GIS 情報を使いまして整備してきたわけです。次のスライドをお願いします。こうした水資源のデータに加えまして、貧困、どこに貧困層が住んでいるのか、そういった社会的なデータも重ね合わせることが、貧困の撲滅、繁栄の協議という目的に貢献することができるということが期待されております。
皆様おはようございます。文部科学省の木下でございます。本日は文部科学省では、学術研究であるとか、研究開発の推進というのを担当しておりますが、地球観測に関して、文部科学省はどのような取り組みを行っているのか、先ほど挨拶させていただきました磯貝が、ジオのプリンシパルということを務めさせていただいております。
Probably you have already known the Millennium Development Goals, which is determined in 2001. And then these Millennium Development Goals are to be achieved by 2015, but some goals are not achieved yet. And for instance, first goal is eradicate extreme poverty and hunger. And then one target is halve the proportion of people whose income is less than 1.25 per day. Now, in this proposal, goal become 8 to 12. And then one goal is
forecast. They don't want to know what the 850 HP, hectopascal potential height is going to be next week, but they would like to know what that means in terms of weather. So, and oftentimes we hear calls for higher resolution and greater temporal frequency and so forth in terms of data, and that maybe is not necessarily the answer. It may be in some cases, but in other cases it may produce too much data or data that again is not necessarily usable.
And also one of the unique points is almost all river basins in Africa is a transboundary river basin. Water basin serve as the basis of the regional cooperation and development. This is our understanding. So in each region, we need to share our essential issue.
Excuse me. After this, actually, I don't like it.
was excellent.
Yeah, this is my business.
It comes last minute, so then
Following up you. Almost the same situation.
I think there are some results on the Volta Basin.
Just for checking.
This approach has fully contributed to rationalize the use of water resources and improve the population lives.
As far as India is concerned, everybody, all of us know that we are contributing to about 2% of the world's land mass and about 4% of the world water.
Now, as you all know, the sustainable development was defined by the World Commission on Environment and Development in 1987 as the development which meets the needs of the present without compromising.
まずは我が国は急峻な地形を持つ島国で、強小な平野部に多くの増していると言えるでしょう。日本国内の水支援政策の観点に戻りますと、日本では高度経済
especially from the African context, to reinforce existing institutions being developed by GEO. We should emphasize and enhance this kind of tools where people can easily get access to data and be able to use it for their own needs.
Due to the rapid economic and population growth and extreme events by climate change, issues of water are now becoming serious issues and more serious. So in addition, appropriate infrastructure or information or data or water governance to address these issues.
Even if you know the global change, especially the demands and for change, in the future uncertainty is a major issue that we have not still really overcome. Now, if we can also get some of these modules from GEO actually to be delivered, and that could also provide a starting point for many other these kind of groups. And I think we need to have some sort of gluing mechanism. What we have tried and found very successful was to have some pilot projects.
There are 2 points. One is knowledge mechanism to further promoting knowledge sharing. The point 2 is extension of networks towards new type of policy groups.
At present, the density of in-situ observation network is not enough to meet the requirements of the modelers and the climate service providers. Data on water cycle includes extensive monitoring of atmosphere, hydrosphere, and cryosphere.
The GEOSS Committee on Earth Observation Satellite, GEOSS claim it's a space arm of GEOSS. This means that GEOSS coordinate satellite data major changes. For the last 10 years, we have major changes in the satellite data trend. One is Google Earth in 2005.
Why is this? Well, it's because people haven't been taking as many observations and they haven't been getting the data in a timely way to the data center. In cases where there isn't a basin authority or there's not an interest in a basin activity, then maybe it's better that we start small, focus on something like the water, energy, food nexus.
NASA or USAID addressing water-related challenges. We have the Pure Water Solicitation. That is a funding opportunity for non-US based researchers to partner with NASA Applied Sciences PIs for water challenges using Earth observations. That's supposed to become active early next year. I just heard about this other RFA that just opened, released by USAID.
You can see in some, month by month, how the vegetation is doing. And this can also serve as an early warning, for example, for agricultural losses. As you go outside, it shows the less intense rainfall. And this can serve as a warning for the possibility of flooding.
There were two products, physical parameter products, are also released at the same website in May 2013. And now, the GEOSS Suzuku data are also used in the process.
And then eventually it's our direction here, which are part is the Earth Observation Directorate, which is now situated in Victoria. Delineate water to add to the normal integration of water cycle, because in South Africa we are relatively lucky that we have got a lot of data available in the country already.
And we also want to make sure that we are effectively developing partnerships that will help us with coordination to the user community. A couple major initiatives that will advance this overall concept. What we see from space often has an explanation in terms of a state policy or a local policy.
Right now we have 20 data providers, as I mentioned. You can see previous slides. And then in the 20 local data providers, there are mostly 65 million data sets in there.
観測地点のところとかその付近ではいいデータが作れるんですけれども、その地域とか変数が限られてしまいます。そこで使うのが数値予報の技術で、数値データ同化で観測データを同化することによって作ります。でこれは使った観測データの数を示します。上の図はコンベンショナルデータで、この辺りの地上データ、それから緑色のデータは、高層データです。
統計140度上の、東アジアから、西太平洋地域をカバーする運用を計画しております。インターネットのどうしても、環境が十分でない、そういった国々のために、通信衛星を利用した、データを絞った形の現状データと同じ程度のですね、その配信も計画。
Under the auspices of UNESCO. From now, I'd like to introduce our challenges for contribution to water-related disaster. You can see ICHAM's philosophy, that is localism. We have 3 pillars, research, training, and local practices.
So what I'd like to promote here is the idea that we are in GEOSS wanting to develop a hydroclimate project in Africa. HIVIC will succeed and the other activities within GEOSS as a function of the panels working together and also WCRP's other core projects working with GEOSS. And the question of how a regional study gets supported is not something that GEOSS can determine. It has to be driven by national support, international involvement.
It means actually if we're using groundwater for drinking, we don't have so much microbial contamination, so is there still a problem? If we look at fluoride, the estimates are higher. Here are about 200 million people. The reasons, again, we're talking about geology. Here are sort of rock types where you have no calcium, because calcium fluoride controls the solubility of water, fluoride.
Okay.
Well, this is the thing about the science, you know, and that's why these questions are so important, because there is could be an opposite view.
Why you can recharge in the front?
Now for the welcome speech, I would like to invite our very special guest from Embassy of Tunisia, Acting Ambassador His Excellency Mr. Mohamed Rumi.
Professor Toshu Koiti, Excellencies,
distinguished guests, ladies and gentlemen. First of all, I would like to express my honor and great pleasure to be in this very prestigious university and to attend the first GEOSS Joint Asia-Africa Water Cycle Symposium that is being jointly organized by the University of Tokyo and the Group on Earth Observations, GEOSS.
Today is a very special day and I'm very happy to invite all of you here with us because November 25th is coincidentally Professor Koike's birthday. Birthday to you, happy birthday to you.
In situ data, but once you expand the deep, especially the
so yung overestimation.
Known for many, many years, we were roommates.
I think really we have an opportunity to test this.
Do people have dental fluorosis?
Yeah.
じゃなくて、たまる水の量を推定するっていうのは私たちの仕事なんで、だから、state for one long time, one location, same officers. The last time,
at this time. The good news is that water is available. We need to find a way how to provide it in a sustainable way to those who need that water. The second security is related to food. And here again, unfortunately, many African countries are still struggling to achieve food security. I'm not saying here this, the food security in terms of quality, like in Western countries where we have other things related to quality issue. Here the issue is on quantity, still, not on quality access. And the main reason is that because agriculture is generally rain-fed.
We came across some of the proposed solutions and also some that we want to work on. Again, they're pretty broad, but again, we're not going to do all this. We're not proposing to solve all problems in the basin, and I'm sure what we want to focus on. So some of the solutions we have is investing and investigating and developing opportunities for use of local aquifers, basically that to address the issue.
On pouvait le constater ici, une baisse justement des précipitations qui sont enregistrées depuis 34 à 2000. Le déficit est à peu près de 30%.
Okay, the problem is that the river basin now is becoming kind of a waste collection point from industrial, domestic and agricultural sources.
De la gestion des ressources d'eau dans la région, dans le cadre du plan Maroc vert qui est lancé par le gouvernement marocain en 2008.
The problem is that these dams are multi-objectives, so also with conflicting objectives. For example, flood protection, drinking water furnitures. Here is an example of the rainfall network. This is here is the major basin.
And the biggest part is in Nigeria when we have 32% of the we have many flood occurrences in the Niger River basins. We have drought situations in the Niger River basins. We have food security problems, as it was highlighted by Abu this morning.
Black, the white, and the OT basins with various contributions of flows. We need to exchange our data with the space agencies and the experts. Yesterday, a number of presentations were made, and we need to share our data with you so that you can calibrate and then we can have very good system there.
There are 24 runoff stations. And then I realized that we have been archiving satellite precipitation measurement. Then it just struck me that I can put off a system and inform these people. And then 91 to 2005, we start seeing an increase in the flow going into the lake Chad. This is the total use of water within the lake Chad basin.
But I can say that usually to establish the hydrology models, we need soil based data and also some vegetal cover. Consider change of the land use at this point. Because we wanted to see the overall ideas of our AWCI domain instead of the details.
And Bangladesh is facing a funnel of Bay of Bengal. That's why the saline water sometimes it also feeds towards Bangladesh at the center. This is the project area, actual project area. In the middle side, as you can see in the brown color, it is brown color is somehow hilly area.
And the third, climate change impact assessment on water nexus. To address these issues, we need to improve. One, to improve water cycle observation network. Then we also develop or improve comprehensive in situ and satellite observation data achieve for improving monitoring capability of water cycle.
And for more than 60 scenarios have been, so they are basically for design floods, for presently what I showed. But similar work we have done for river Ganges for its 250 kilometer reach in Bihar but that I did not show anything. So these are for design floods, similar can be for the
downscaling and bias correction, such kind of the system or the output data do you need? You need some system which you can use.
Exactly, sir.
As now we are in AWCI, we are supported by AWCI, and also, for example, with Tokyo University, one of the important partners. And it's the criteria that developed by BMKG, so we just, not BMKG, National Drought Mitigation Center, we just use it. Bias correction.
This one is topography of Lao PBR with combination between the mountains and plateau of almost 200,000 square kilometers. The floods and droughts. So the floods have the greatest macroeconomic impact on the country and affect a greater number of people.
The interface for the users, whether the data they observe is actually correct or not, comparing with related area or nearby area or different types of sensor values and so on and so forth. So by using these tools, the quality of the observed data is significant.
However, prior to this disaster, better than flight had focused in this area in 1996, 2000, and 2008. So with this kind of disaster, and with the onset of the climate change, the situation in Batam Valley, Emerald Island, has been dire. So that's why we choose this project.
Size water balance in the polar river basin. That's very important basin for my country. This is the concentrated populated basin.
Also the low upland suburb of the frequent floods and AFD associated economic productivity. Installation the automated hydrological and meteorological equipment, such as the automated water level gauge and automated weather observation system.
Before, on the right is just 1 hour after. It took place in the 5th May 2012, where we lost 31 lives and 40 still missing.
So, keeping in mind that we are going to propose
on a project improving water cycle observation and prediction of hydromet disasters in Pakistan. These are the first work packages to develop long-term climate trends and short-term climate variability.
Extreme flood events, and just to show some pictures, in 2004, areas in northern and central Luzon were devastated by floods caused by 3 typhoons that occurred one after the other. And then in 2006, another flash floods in the province of Albay.
Start, you get rainfall as high as about 4,000 millimeters per year. Here it is about 1,500 millimeters per year. And analyzed the rainfall, future rainfalls, and found the rainfalls of different return periods that we expect in the future, and those were input to the hydraulic model.
What happened in this mountain area, we can get the rainfall in the windwatch. And after that, from the mountain area is the rainfall reduced from 2,000 millimeters per year to. But if we have a good model, we can do exactly to the people accuracy. We have need more model here. And some of the area we have no rain gauge station. We use about satellite for the purpose of gauge station.
Degradation of glacier, reduction of available water resource, strengthening of natural vulnerability, and the overall trend increase in extreme water availability in years. Tajikistan, and now we have not regular data from this neighboring country.
Program and part of our Taiping River Basin. This is why we have several projects to improve flood forecasting for this system. But for this mountain area, we have no station.
Well, we're going to deliver an expert for 3 months to work with you on this program.
This is connected to the line ministry.
This is very important for the commitment and also for the sustainability of the process.
We have several agencies looking after this climate change in various perspectives. Me, as for example, in the irrigation department, Ministry of Irrigation, hydrological and meteorological stations.
Assist them in a way in rehabilitating some of the measuring stations that they have established.
Risk reduction and then climate change.
I also believe that we don't have too much choice than matching or aligning our proposal with the donors. The area where the donors are willing to put the money in the basket.
So maybe this may be a project, a new project to be built into the African Development Bank.
International coordination sector, they will put the priority. And our proposal needs a higher priority. So that's why the mainstream is a very important. African Development Bank can do something, but the African Development Bank can propose to the global environmental facility, which is a higher level.
I know something that's sort of worked for NASA and USAID, that partnership, is to actually get someone from NASA to do a detail at USAID. And in doing so, you allow USAID to access the technical expertise of that NASA person.
What we have not yet demonstrated is how do we apply this new technology to solve real issues in the river basin. So operations is very, very vital. Let us not forget it.
Government people are also invited so that they can understand the sensitivities of the issues which we were discussing. That will improve the awareness.
interdisciplinarity. So this kind of the comprehensive knowledge we can provide to the society.
Because we can see this GCM data, GCM results are changing and more accurate predictions are coming on. And
they do not collect data themselves. They have MOUs with the member countries, and it is through these MOUs that they receive data.
Users, scientists, decision makers, and IT technicians, engineers, and the problem is how we can communicate each other.